and we are going to use Tiva launchpad, and we have the two onboard switches available on the launchpad, and there's a special case where we are going to work on switch 2, because switch 2 is connected to PF0 of port F, and where this particular register is actually a lock, and we will have to unlock and then make the switch read, and that we are going to do it with register level coding. And here we have GPIO reads 0 when the switch is pressed, and GPIO reads 1 when the switch is released, and we can use an internal pull-up register by configuring the register. And now let's get in the code, and here we have the basic register level coding for the switch. And if you want to know more about register level coding, like how to read the registers, you can watch my video on register level programming using Tiva. Also, I'll provide the same in the video description. And here, coming to the switch code, here we have the system configuration code. This is the particular register where we will have to make the system configuration, and then we have system port F peripheral and clock enable, and then we are configuring the digital pins, that is to make the pins digital, where both LED, we are going to use LED and switch to check the output and read the input. And so we have the particular pins to configure as digital, and then we have the direction set, that is here LED is going to be output, so we have enabled that as 1, and then if it is 0 in the register, the port direction register, if it is 0 it is the input, and if it is 1 it is output. So we have configured accordingly. And then we have the as discussed, we have the pull-up resistor, so which can be configured using register. And here PF0 is the pin where the LED switch is connected. So we are going to enable the pull-up register in that particular bit. So here it is a least significant bit, that is PF0. And now we have a variable which reads the status of the switch. So when the switch is pressed, you should get 0, and when the switch is released, you should get 1. And accordingly, we have the LED switched on and off. And if you work with this code and configure the switch 1, what happens is this code works fine, but that doesn't happen the same with the case of switch 2. Let's check that output now. And here I am uploading this code. So now the code is uploaded. So what you can see here, we have a display. I'm trying to press switch 2, and I'm not getting the output. You can see that just an LED is on. There is no toggling of LED when the switch when I press the switch. And now we are going to make some changes, which that we are going to unlock the register by using a unlock code. So that is mentioned in the datasheet that we can discuss. Here you can see we have GPIO lock register, and here and commit register. These are the two registers which we are going to use, and you can see here our write of value 0x4C 4F434P unlocks the GPIO commit registers for write access. So we have to configure the commit register, as well as we will have to use this particular 32-bit value to unlock the GPIO. So that we are going to try now in the code. And so I have the lines which I'm going to add here, and now I have pasted these two lines, and this is the unlock code, that is 4C4F434B, and then we have the commit register switched on for a particular bit, that is PF0. And now what I'm going to do is now upload the code and check the output. So let me build the project. So the project is built. Now I've uploaded the code, and now you can see you have the output displayed here, and now I'm trying to press the switch and you can see the output. Now the switch works well. So when you write register level coding, you might face this problem, that is like that particular switch with onboard switch will not be working when you don't use this unlock code. And this is what I wanted to tell you in this video. I believe you understood what I explained you today in this video. So we'll meet in another video. Thank you. Thanks a lot.